Hey guys, so today we're going to look at another algebraic method on solving a system of equations. In today's case, they will be nonlinear, meaning one of them, for the example, will be quadratic. So it's not a linear function, it's a quadratic because the highest power is x to the second power. So just note the steps for substitution. You want to set it up first by getting one variable on one side of the equal sign by itself. So notice that step one has already been done. The first equation y is on one side of the equal sign by itself. So we already know what y equals to, which sets us up for substitution because for step two, we're going to substitute the expression of the variable into the other equation. So meaning I'm going to take this second equation, the one that doesn't have what y equals to, and I'm going to rewrite it and I'm going to substitute y with what it tells me it equals to from the first equation. So remember to always substitute expressions, anything with plus or minus in parentheses. So instead of minus y, it's going to say minus and what y equals to, which is x squared plus 3x minus 7 equals -2. So all I did was rewrite the second equation, substituting in the y with what it equals to from the first equation. So from here, I'm just going to solve using the second equation. I'm going to simplify first because there is a parentheses, which means I can distribute that -1 in front of the parentheses to get rid of the parentheses, and that'll give me negative x squared. -1 times 3x is -3x, and -1 times 7 is +7 equals -2. And we're going to combine like terms from here. So I'm going to write it in standard form by putting the largest exponent to smallest exponent. So the -x squared will be first. Try to find any like terms you can combine as well. So I have 3x minus 3x. So 3 minus 3 would give me 0, which means that 3x is gone. I'm going to bring down the +7. And then that it equals -2. So from here, this is a quadratic, but there's only one term with x. So you have two methods from here. You can make one side equal to 0 and factor to solve. You can make one side equal to 0 and use quadratic formula. In this case, since there's only one term with x, I am just going to isolate it, meaning get it by itself by subtracting 7 on both sides. And I have -x squared equals -2 minus 7, signs match, so I add, take the sign of the bigger number. So my goal is to get x by itself. So I'm going to get rid of this -1 by dividing both sides by -1. So when you isolate x, you're actually just doing PEMDAS backwards. So multiplication, and then I'll get rid of the exponent. So this will give me x squared equals 9. And then, last step, I'm going to get rid of the square by square rooting. So remember that the square root of 9 is not just 3, it's positive and -3. So I have two values of x, +3 and -3. So once I solve for the variable, I'm going to substitute the value of the variable into one of the equations. It really doesn't matter which one you choose to substitute x into, and we'll have to do it twice because there's two values for x. But I'm going to choose the first one just because it already has y equals 2 set up for me. So with that noted, I am going to go to the next page because I'm out of room. Go to a blank page that's next to type in what I have. And then from here, remember that x equals to +3 and x equals -3. So those are my x values. I'm using the last step of substitution by substituting the value of the variable into one of the equations. And again, I chose the first equation. So I'm going to rewrite that first equation. Y equals x squared plus 3x minus 7 And then I'm going to replace the x with 3. Remember PEMDAS. So exponents first. 3 squared is 9, plus 3 times 3 is 9, minus 7. And then when it's adding and subtracting, you just go from left to right. 9 plus 9 is 18. 18 minus 7 will give us 11. So 1 point is 3, 11. And that's one of our xy solutions. If I replace the x with negative 3, which is my second value of x, I get y equals, anytime I square negative, it's going to be positive, which is 9. And then I have 3 times the negative 3 this time, which is minus 9, and then minus 7. So adding and subtracting from left to right, 9 minus 9 is 0. 0 minus 7 is negative 7. So my second point, when x is negative 3, y is negative 7. So these are my two x values when I solve for the equation. That means if I were to graph both of those functions, or both of those functions given to me here, there would be 2 points of intersection, and they would be at these 2 points. In case you guys wanted to confirm the answer using Desmos, you can type in the equations we're given, y equals x to the, which is shift and 6, second power, plus 3x minus 7. That would be my first graph. And then the second one will be 3x minus y equals negative 2. That will be my second graph. And notice that if I were to zoom out, I have 2 points of intersection, one at negative 3, negative 7, which is one of our answers, and the other one at 3, 11, which is our other answer, which confirms that our substitution method was correct. All right, guys, hope this helps.